If we strip away the planets, the stars, and even the laws of physics, we are left with a single necessary starting point. That starting point is possibility. Gonçalo Melo de Magalhães defines this as available paths, the idea that before a system can move or exist, there must be a structurally permitted sequence of states for it to occupy. While we often discuss freedom in a political context, this theory treats it as a fundamental building block of the universe. Here, freedom is the objective, physical availability of those paths. The theory proposes that this logic extends even to the Big Bang. For the transition from a void to a universe to occur, the possibility of that transition had to be structurally permitted before the event itself could unfold. In this sense, freedom serves as the irreducible cause of reality, the prerequisite condition that makes existence possible. If freedom is a structural condition of nature, it should follow a measurable law. Magalhães formalizes this as a specific equation, F equals P divided by D. In this calculation, P stands for perception, or the system's capacity to differentiate between available paths. D stands for distortion, representing the structural resistance or friction that limits a system's movement. Dividing a system's ability to see alternatives by the resistance in its environment provides a calculation of its effective freedom. This formula shifts freedom from a philosophical debate into the territory of engineering. We can calculate it, predict it, and potentially manipulate it. We'll start with the denominator, distortion. This is the structural resistance that opposes movement, including physical objects, friction, and distance. Consider a river carving through a canyon. The density and shape of the rock walls create the baseline distortion field for the water. The water cannot change the rock's hardness. Instead, it continuously adapts to the resistance, seeking out the geometry the canyon permits. The math is direct. As distortion increases, as the path becomes narrower or the rock harder, the effective freedom of the water decreases. Distortion acts as a universal constraint. It is the friction that forces systems to find more efficient routes to survive. To navigate that resistance, systems employ the numerator, perception. Within this law, perception measures a system's capacity to distinguish between different available paths. You can observe this at a microscopic level. A firing neuron actively differentiates between chemical pathways, seeking the route with the lowest resistance. Ant swarms exhibit the exact same logic. They branch out until identifying a viable food source. Then the colony snaps into a single efficient line. Both the neuron and ant swarm attempt to maximize their freedom by increasing perception, their ability to find the easiest route through their environment. Perception functions as nature's response to friction. It is the mechanism that prevents systems from endlessly colliding with physical constraints. Rivers, neurons, and ant swarms are all obeying a single mathematical directive. This is the lightest path principle. Every system navigates toward the path of minimum perceived resistance. The yellow path here illustrates the relationship between a system's intelligence, P, and the environmental resistance, D. This process is a structural necessity, operating independently of conscious choice. Nature isn't choosing a favorite route. It is performing a continuous architectural calculation to sustain its own existence. In human civilization, we face a specific problem. Physical space acts as a persistent distortion field. Architecture has high inertia. In a static environment, we cannot easily remove walls to reach a destination. Movement is trapped. Effective freedom is low because the distortion of the walls is high, and the perception of alternative routes is minimal. Because we cannot move walls on command, human efficiency remains limited by geographic and spatial inertia. The formula offers a way around this. If we cannot lower distortion by moving walls, we must mathematically override space by increasing the system's perception. The physical architecture of the Aveiro building in Portugal serves as a real-world testbed for this exact application. By layering real-time data over the environment, designers create a smart space that bypasses structural resistance. Expanding the user's perception effectively reduces friction. The walls haven't moved, but because people can see more available paths, their effective freedom has multiplied. Magalhães argues that design acts as a mathematical override, allowing us to use data to navigate through the rigid constraints of spatial distortion. In this framework, we can define human intelligence as the active removal of distortion, the capacity to make a complex system more navigable. Whether we are looking at a river or a city, the rule remains the same. The lightest path will always prevail. This perspective suggests that a primary goal of science and design is to master the engineering of possibility itself. We are moving toward a time where we can treat the availability of paths as something we can actively construct. Freedom is a precise engineering parameter. We are learning how to build it.